Okay, number one on the calculator section is a limit question. It asks you the limit as h approaches 0. For this thing, we really have no idea what this looks like. You maybe could recognize this as a difference quotient, but that all said, my first instinct was I wanted to graph it, so I'm going to show you in the graphing calculator. Let's see if I can find it so you can see it here. You should see how I plugged it in with parentheses for the top. So when you hit graph on a Zoom 6 window, here's the graph you're looking at, and we're looking for the limit as x approaches 0. So currently I can't see what happens at 0. So I'm going to go to my window. I'm going to change the y max, and after some guessing, you needed to be around 70 or 80, I think, to get a good picture. So I hit graph. This will take a second to show up. But again, remember, I'm looking for the limit as x approaches 0. So if you look at this graph here, you notice there's an undefined spot at 0. If I trace, it's still thinking, give it one sec. If I trace to 0 and hit enter, you'll see that it does not give you a value. It's probably hard to see, but if you're doing it at home, it doesn't give you a value for 0. But since I'm trying to get really, really, really close to 0, I'm going to trace to 0.0001. And when I hit enter, you'll see on your calculator it gives you 54.6. So 54.6008. And if I trace to negative 0.0001, you'll see it's pretty much the same answer, 54.595. Again, about the same answer. So if I want the limit, I know the limit now as h approaches 0 is approximately 54 point whatever. So I want to look at my choices now and say, well, which one of these is equivalent to 54 point whatever? Well, we know E is 2.71. That's gone. Well, the number 1, that doesn't make sense. E to the h would be e to the 0. That's 1. That doesn't work. E to the 4th. So you go in your calculator and you say, well, what is e to the 4th? And e to the 4th is, there's your 54 point whatever, giving you an answer of D. For number 2, you'll see a d dx. Your top bound is an x, and you're plugging into a t. So if we're taking the derivative of an integral, we're going to wash all of this out, but we're going to plug in the top bound. And if your top bound is anything more than x, we want to do a chain rule in addition. So this is sine. When I plug in 2x, 2x squared is 4x squared plus 1. And then our chain rule is the derivative of 2x is 2. So you'd be looking for 2 sine 4x squared plus 1. That's choice A. For number 3, the question asks, where is there a change in concavity? So if we're talking about concavity, we're talking about the second derivative. So the first derivative would be bring the 3 down. 3 times a third goes away. So we have x squared minus 2x minus 5 plus 3 cosine x. The second derivative would be 2x minus 2. This 5 will go away. When we take the derivative of 3 cosine x, cosine goes to negative sine. So minus 3 sine x. So now that we have a second derivative, you'd want to go to your calculator, go to y equals, and we want to plug in 2x minus 2 minus 3 sine x, and do a zoom 6 to reset your window. So you're now looking at the graph of the second derivative, and we want to find where does this second derivative cross the axis. Where is it at 0? So you can look at it and you see if you're doing it on your calculator, it's about between 2 and 3. So if you look at the choices, 2.21 would be the best guess, right? So if you trace to 2.21, y is 0.01, so very, very close to being a 0. So the answer is choice B, 2.21. For number 4, they tell you the integral from 1 to 4 of f of x is 3.8. And then they also tell you that capital F prime of x is equal to little f. Well, if we go backwards by integrating, you could say big F is equal to the integral of small f. So if I just integrated both of these going backwards. So if you look at the graph given, it tells you from 1 to 4 is 3.8, and that's written right here. So they're saying the actual question is then big F of 4 minus big F of 0 is equal to, well, if we just said big F is equal to the integral of small f, this whole question really just means find the area under the curve from 0 to 4. Well, we already know from 1 to 4, according to this right here, is 3.8. So if 1 to 4 is 3.8, and I'm trying to find 0 to 4, you need to do a geometry from 0 to 1, making that a rectangle. So if I find the area from 0 to 1, just treating it as a rectangle, it's 1 across and 3 up. That tells me that this part right here that I just shaded has an area of 3. So if I add that 3 onto the 3.8 that was already given from the integral, 3 and 3.8 would give me a total of 6.8, choice D. For number 5, it says y is equal to 3x plus 6. What is the minimum value of x to the third y? Y is equal to this. I'm going to plug it in. So I have x to the third times 3x plus 6, giving me 3x to the fourth plus 6x to the third. So I can just look at this in the graphing calculator, and it wants to know where is it at a minimum. So if I graph this 3x to the fourth plus 6x to the third, oops, I didn't graph that right. 3x to the fourth plus 6x to the third, and we hit graph on Zoom 6. We want to know where is this at a minimum. So the trick to this problem is realizing that the minimum is the y value here, not the x. So if you think back to Algebra 2, so here's the graph right there. So I'll give you something similar to look at. So if I told you this, and we said here's, so it looks similar to that. So this value right here, let's just call it b, and we'll call that a. So we can see by looking at the graph, the minimum is right here, but then the question becomes, do we refer to the minimum value as the x value or the y value? Well, if you think back to Algebra 2, remember when we used to look at quadratics, and then they used to ask you, is this the max or the min? Remember the min was always the y value of the vertex? Well, it's the same thing here, it's just it's not a parabola, but it's still the y value. So this coordinate right here, if you graphed, let me get you the exact one, I believe it was at negative 1.5, yeah, so this is at negative 1.5, comma, negative 5.0625. So most people that got this wrong put the negative 1.5. So unless it would specifically say what is the x value of the minimum, then by default you're looking for the y value. So in this problem you were looking for negative 5.065, which is what we got whenever we graphed this right here. So negative 5.0625 is choice B. For number 6, it gives you f prime of x is equal to 2e to the x minus 5x squared, and it says which of the following values produces a relative maximum. So again, let's think you're being given a derivative. So my first instinct would be let's graph the derivative they give you, and when you do that, so it's hard to see this on the calculator, but you get something if you're doing it at home that looks like this. Okay. And if I want a maximum, it means I want to know where it goes from positive to negative. So if I highlight my critical values, again, remember this is f prime, the graph of, so if I want a maximum, remember what a maximum looks like. It means it has to go from positive to negative. So this one goes from negative to positive, so that's a minimum. This one goes from negative to positive, that's a minimum. This one right here goes from positive to negative. This one right here is your maximum. So if you look at the choices given, it's approximately 3.310, choice E. Okay, for number 7, they give you two graphs, y is equal to sine x, and they give you y is equal to 2 minus x, and they want to know the area bounded between these two. So this is the one we did on the board in class where, so I have a graph sketched here. I'm trying to find this area underneath here. So to find this area, I need to find this intersection point between the two graphs. So you want to graph these two, maybe do a zoom fit or a zoom box or a zoom in, set the window somehow so that you highlighted this area right here. And I want to find this intersection point between these two. So if I find that intersection point on your calculator, second trace calc, go to intersection, enter, and line up the guess. It appears that the intersection is at 1.106. So I'll scratch out the question mark here. 1.106. So now if I separate this into two integrals, the blue one here is the sine curve. So if I go from there to there of the sine curve, so the integral from 0 to 1 of sine, and then plus the integral from 1.106 to 2. Now we wanted to test and make sure, but if you do in your calculator, you'll see it's right at 2. Also, notice this is 2 minus x. There's a typo in the problem on your paper. It's not y equals 2, it's y equals 2 minus x, if you're wondering where this line came from. The second integral here being 2 minus x. So if you run the math on these, let's do it real quick. We would do, so to find these, you want to hit math 9. You can also do it on your graphic window. If you do second trace calculate, you can calculate these and show them visually on your screen. But if we do math 9 and set up the integral from 0 to 1.10, 1.106. 1.106 for sine x dx, you get 0.5571, 17 plus, then you want this one over here, so do again math 9 from 1.106 is where you left off, going up to 2 for the equation 2 minus x dx. You hit enter and you've got 0.3996, and if you add these two up, you get 0.9513, 0.9513 roughly. Looking at our choices, 0.95, choice C. Okay, for number 8, asks you about these two particles and the path they take. It's asking when would they have the same acceleration, and the key to this is that it's over the time interval 0 to 6. Because if you don't set your time interval, you're going to find more intersections than they ask for. So if you want to find the acceleration, you need the second derivative. So the first derivative would be cosine goes to negative sine, so negative sine 2t, and it's 2 from the chain rule, would make the second derivative negative 2, sine goes to cosine 2t, again a 2, so we're going to change this to a 4. Finding the first derivative of the other particle, you would have 4 cosine t, and then the second derivative would be cosine goes to negative sine, so negative 4 sine t. So we have 1, we have 2, and now you want to graph both of these and go from 0 to 6. So for your x, you want your x min to be at 0, and you want your x max to be at 6. So now looking at what you want for y values, the standard's fine. You see you have an amplitude here of 4, so I would at least make my y max 5 or maybe a little more. So the idea now is to graph both of these. So let's do that. Negative 4 cosine 2x, close it, and negative 4 sine x, close it, Window, again, we're going to set from 0 to 6 for the x's. And for my y values, I'm going to go, let's try -5 to 5. So when we graph that, we see the first one coming up, back down, back up, and then we'll be waiting for the second one. So I see one intersection, curves down, two intersections, and then try to hold this up so you can see it. It's hard though. So the third intersection at the top of the hill, even though it looks like it might or might not cross, you can actually find an intersection up there, and it does cross at the top of that. So you have a total of 3 intersections from 0 to 6, so choice D. Number 9 says the limit as h approaches 0 for all of this stuff. What do we see? It's sine pi over 6. This whole thing tells me that if I had the function f of x is equal to sine, it really asks me to find f prime of pi over 6. So the derivative of sine is cosine, and then cosine at pi over 6. Cosine at pi over 6 is 30 degrees, gives me an answer of √3 over 2. Number 10 says state the value c that satisfies the mean value theorem for, and they give us a function. So the first thing we need to do is know what the mean value theorem says, and it says that f prime of c is equal to f of b minus f of a all over b minus a. So what does this actually mean translated? If I had, let's just make a sketch. I said here's a graph, and I said this is a to b. If this function is differentiable and continuous, the mean value theorem says that there is, if I find the average change from a to b, and we refer to this as the secant line, and from a to b to find that, that's just the slope as you know it, f of b minus f of a over b minus a, so the y values minus the x values. If this is differentiable and continuous, then somewhere on here is a value c such that its tangent line would have the same slope as the secant line. So the tangent slope we're saying is f prime of c, because you find the tangent by taking the derivative. So this problem says state the value c that would satisfy this. Well, the first thing I need to do is find what is going on the right side of this equation. So I want to find, so I'm going to scratch this graph out now so you don't get confused. I want to find this f of b minus f of a. So to do that, I plug in 3 into this equation, and I plug in 1 to this equation, all over b minus a. Well, b minus a is 3 minus 1, which is 2. So now we need to see what's going on up top. If I plug in b, so if I plug in 3, 3 squared is 9, negative 18, negative 21, negative 19. If I plug in 1, we've got 1, negative 2, negative 3, we've got minus negative 1. Doing our math, double negative means to add, is negative 18, which is negative 9. So by all of this, it says f prime of c is equal to negative 9. Well, if I want to find what c is, and I want f prime of c being this, I need to find f prime. Well, f of x is this. In other words, find the derivative. So f prime would be negative 4x minus 1, and I want to set this equal to what I just said it should be, negative 9. Going through and solving, I add 1. Negative 4x is equal to negative 8. X is equal to 2. And that is choice D. Number 11 gives you 2 integrals to compare with, and it says find from 0 to 2 of f of x. Well, for the first one, 0 to 50, there's a 3 out front. So notice this one over here is just f of x. So if I wanted this one to be just f of x, we can say that from 0 to 50, f of x is equal to 1. And then, so if I illustrate that from 0, not really illustrate, but I'm just using a number line here, from 0 to 50, that result is 1. And from 2 to 50, that result is negative 4. They're asking me to find the length, the integral, the result from 0 to 2. So So if you just compare these graphically, if I want this piece right here, in other words, from here to here, I should take this whole thing minus this whole thing. So 1 minus -4 is equal to 5, and that is choice D. Number 12 says that big F of x is equal to the integral from 0 to 8x cosine t. It says f prime. So if you want f prime, it's the same thing as d dx. So you want to think of it as all of that going away. So, because we're taking the derivative of an integral, so I'm going to plug in the 8x. So this is cosine 8x, and then we chain rule, and we put an 8 in. So that's my f prime. And then it says find f prime of pi over 7. So f prime of pi over 7 is equal to 8 cosine of 8 pi over 7. So you have to recognize that this is a calculator question because we do not know anything about pi over 7 with cosine from the unit circle. So make sure your calculator is in radian mode by hitting mode. Make sure radian is highlighted. Go back. And let's find the cosine of 8 pi divided by 7. And then I'm going to take that times 8. And we're looking at approximately negative 7.207, choice B. Number 13 says using n equals 3 trapezoids, find the error when using a trapezoidal approximation for, and we're going from 0 to 1 sine of pi x dx. First thing I'm going to do is find the real integration, because to find the error is going to be real minus your estimate, and in this case your estimate is a trapezoidal estimate, so we want to do the real minus the trapezoid, and that would give you the error. So I'm going to hit math number 9 from 0 to 1 of sine pi x, close it, and then dx, enter. It looks like 0.6366 is the real, 0.6366, and then minus, we want to find the trapezoidal estimate. So now back to the beginning, using n equals 3 trapezoids from 0 to 1. So let's think about that would look like from 0 to 1. If I'm going to make 3 trapezoids, that means each one would have a width of 1/3. So this would be a third, that would be a third, and that would be a third. Okay. So now to find all these points, the easiest way to do this is to go to y equals and graph the function we just had. So I'm going to graph sine pi x and do a zoom 6, and let's see what this looks like. So you see a whole bunch of sine curves coming. So another way to do this that might be easier for you is to change your x from 0 to 1, because that's what we're integrating. So I'm going to go ahead and do that. So window, x min 0, x max 1, hit graph, and now you have a much more focused picture. So we want to find all of our trapezoidal sides. So I'm going to just kind of exaggerate them out. So trace 0, enter, gives me 0. So even though I have a side length there, I'm just going to put 0. So this is at 1/3, and this is at 2/3 on the graph. So if I trace to 1 divided by 3, which is 1/3, I get 0.866. So this one right here is 0.866. If I trace to 2 divided by 3, same thing, 0.866. If I trace to 1, I'm at 0. So now I have the dimensions of all 3 trapezoids, and as a reminder to find the area of a trapezoid, it's add the 2 bases up. So it's add this and that, divide that number by 2, and then multiply by the height which is going across. So 0 plus 0.866, just put all of this in your calculator, would be 0.866. Divide that by 2 and then times it by 1/3, or also just divide it by 3 again. Gives you the first trapezoid is 0.1443, so on. If you look at the last trapezoid, you notice it has the same dimensions. One side 0, one side 0.866 with 1/3 on the bottom. So that tells me it should have the same result since all of its sides are the same. And then we want to do the middle one, which has different dimensions. So it's 0.866 plus 0.866. Enter. divided by 2 times 1/3, 0.2886. So if we add these up, let's see what we get. Appears to be 0.5772. So over here, the trapezoid is 0.5772. So to find the error, we want to do the real minus the trapezoid. So 0.6366 minus 0.5772 is 0.0594. Looking at our choices, 0.059 looks to be choice D. For 14, it says acceleration is given by a of t is equal to 3t squared minus 2t, and the initial velocity is 0. So initial velocity at 0 would be 0. For how many values of t does the particle change directions? So if you want velocity and you're given acceleration, we want to go backwards. So you'd want to integrate this. So velocity would be equal to, add 1 to that, and you got 3 over 3. So 3 over 3 gives you t to the third minus 2t squared over 2 is t squared. So now that I have velocity, I want to set it equal to 0. So t to the third minus t squared is equal to 0. Factor out a t squared, and you're left with t minus 1, giving you t is equal to 0 and t is equal to 1. So you have to be really careful, because just based on algebra alone, first instinct you would say, well, I got 2 answers. There's 2 places where the v is 0. But if you were to graph this, what does it say? It says that the initial velocity is 0. In other words, this problem starts at 0. So you would have a graph, something that would look like this. I'm just making this up. But if you looked at it, this is the initial velocity. It means nothing was going on yet, so it did not change direction here. It started here. So even though it's at 0, nothing had changed directions here. So the only time it changed directions was at that 0 there. The correct answer is choice B. Question 15 says, given the following function, and it's differentiable everywhere, n and m are constants, what is n? So if it's differentiable everywhere, that means if I took the derivative of all of this, we should be able to set them equal to each other. Also, we're going to let x be 1 here, so let's do that first. So if I let x be 1, what would we end up with? This would be n minus 1. If it's differentiable everywhere, it should also be continuous everywhere. So let's see if that takes us anywhere. N minus 1 is equal to m, plugging in 1, plus 5. If we solve for n, n is equal to m plus 6. So that's a start. Let's see, what could we do with that? N is equal to m plus 6. We don't have anywhere yet to plug it in. But if we took the derivative of each of these, this would be 3n x squared minus 1, because remember n is a constant and m is a constant, and the second one is 2 mx, the 5 would go away. Remember x is also 1, so 3n minus 1, this x here I plugged 1 in for, and let's set it equal to 2m. If we go to solve this, 3n is equal to 2m plus 1. And what do we know about n from over here? N is equal to m plus 6. So 3m plus 6 is equal to 2m plus 1. 3m plus 18 is equal to 2m plus 1. Subtract the 2m to the left. M is equal to, subtract the 18 that way. M is negative 17, so if I take that back this way, n is equal to negative 17 plus 6. N is equal to negative 11. Choice D. Question 16 asks you to find the average value. So we want to set up 1 over b minus a. b minus a would be 1 over 4 minus 1, which is 1/3. From 1 to 4, 2x ln 2x, this whole thing dx. So we do not know how to integrate this, so we are going to plug into your calculator. Let's do math 9, and then we want to type in from 1 to 4 of 2x ln 2x, and close it. We want to close it twice because there was 2 that were open. Dx, hit enter, and it gives you 25.077 is the result of the integral, times 1/3 or divide by 3, and you should be looking at 8.359. 8.359, also very close to 8.360, choice B. Number 17, hopefully we recognize this whole thing as a difference quotient, so minus the original. This whole question really says f of x is equal to the natural log of x. It wants us to find f prime of 1. So f prime means take the derivative of the natural log of x. The derivative is 1 over x. If I plug 1 in, I've got 1 over 1, which is 1, choice E.